Hello everybody, so we will be learning more about Laplace transforms, and if you need to know anything more about Laplace transforms or the introduction behind it, feel free to watch my earlier lessons. So today is basically a question and answer session where we'll be discussing about 3 questions, and each of them covers various aspects of Laplace transforms. So question 1, find the Laplace transform of ft equal to sine at by t. Now the Laplace transform is denoted by f bar s, and f bar s is a by s squared plus a squared for sine at. Now Laplace transform of ft by t is same as integral s to infinity f bar s ds. So Laplace transform of sine at by t will be integral s to infinity. Sine at by t, sine at the Laplace transform is a by s squared plus a squared ds. So integrating this integral of 1 by s squared plus a squared is tan inverse s by a into 1 by a. We take out this a, so you get a into 1 by a tan inverse s by a within the limits s to infinity. And when you substitute the limits, you get the a gets cancelled, tan inverse infinity minus tan inverse s by a. What is tan inverse infinity? Pi by 2 minus tan inverse s by a. Now we have a formula in inverse trigonometry, namely tan inverse theta plus cot inverse theta is pi by 2. So pi by 2 minus tan inverse s by a will be cot inverse s by a. The next question, evaluate integral 0 to infinity e raised to minus at minus e raised to minus bt by t dt. So again it is of the form lft by t, which is integral s to infinity Laplace transform. So L e raised to minus at minus e raised to minus bt by t will be integral s to infinity Laplace transform of the numerator e raised to minus at minus L e raised to minus bt dt. Now what is Laplace transform of e raised to at? It is 1 by s minus a. So this becomes integral s to infinity 1 by s plus a, because you have a minus at, minus 1 by s plus b ds. So integrating you get log s plus a by log s plus b. Technically it is log s plus a minus log s plus b within the limits s to infinity. But what is log a minus log b? Log of a by b. So substituting again you get log infinity by infinity, that is log 1 minus log s plus a by s plus b. What is log 1? It is 0. So it becomes minus log s plus a by s plus b. Now we have a property that log a raised to m is m log a. So if I take the minus inside, it becomes s plus a by s plus b raised to minus 1. And that becomes log s plus b by s plus a. This is integral s to infinity. So if I take integral 0 to infinity and put s equal to 0, the answer will be log b by a. The next question, find the Laplace transform of 2 raised to t plus cos 2t minus cos 3t by t plus t sin t. So we split it into 3 functions. Let ft be 2 raised to t. So Laplace transform of ft will be Laplace transform of 2 raised to t. You can write 2 raised to t as e raised to log 2 raised to t, because the base is the same. That is e raised to t log 2. Now we have the formula for Laplace transform of e raised to at as 1 by s minus a. So what will be Laplace transform of e raised to t log t? Your a is log t. It becomes 1 by s minus log 2. Coming to gt, let gt is cos 2t minus cos 3t by t. So Laplace transform of gt will be integral s to infinity of the numerator, that is L cos 2t minus cos 3t, and that will be integral s to infinity s by s squared plus 4, because Laplace transform of cos at is s by s squared plus a squared. So Laplace transform of cos 2t becomes s by s squared plus 4, and what is Laplace transform of cos 3t? S by s squared plus 9. So here when we integrate it, we can make a substitution in both cases, put s squared plus 4 as t. So when you get 2s ds equal to dt, and again substituting within the limits, you get integral s to infinity. So when you simplify and integrate, you get half log s squared plus 4 minus half log s squared plus 9 within the limits s to infinity. So we're using a lot of properties of log as well, which we used in the last case. Log a raised to m is m log a, and log a minus log b is log a by b. So this becomes log s squared plus 4 by s squared plus 9 raised to half within the limits s to infinity. Again, when you substitute, you get infinity by infinity is 1. So log 1 minus, this is log root s squared plus 4 by s squared plus 9. That is log, if I take the reciprocal, you get log root of, actually this is log s squared plus 4 by s squared plus 9 raised to minus half. So if we switch the numerator and denominator, it becomes log s squared plus 9 by s squared plus 4 raised to half. That is log root of s squared plus 9 by s squared plus 4. Now coming to the last function, that is ht equal to t sine t. So let ht be t sine t. Now we have this property that L t raised to n ft is minus 1 raised to n nth derivative with respect to s of Laplace transform of s of f. All these we have discussed in my earlier lessons, so you can use my playlist or refer to the earlier videos. So LHT here will be minus, it is L t sine t, that is minus n is 1 d ds of Laplace transform of sine t is a by s squared plus a squared of sine at. So this becomes 1 by s squared plus 1. So what is derivative of 1 by t minus 1 by t squared? So it becomes, the minus goes, you get 1 by s squared plus 1 the whole squared. Derivative of s squared plus 1 is 2s. So we call this 3. Now we just add up 1, 2 and 3. So the answer will be Laplace transform of 1, 2 and 3. That is 1 by s minus, it will be 1 by s minus log 2, and then you get 2 will be log square root of s squared plus 9 by s squared plus 4, and then you get plus 2s by s squared plus 1 the whole squared. We're just putting this together. I'll conclude with one more question. Find the Laplace transform of t sine cube t minus cos cube t. Again, we're using trigonometry. Sine 3 theta is 3 sine theta minus 4 sine cube theta. So sine cube t, when you shift the, when you make sine cube t the subject of formula, that becomes 3 sine t minus sine 3t by 4. Again, cos 3 theta is 4 cos cube theta minus 3 cos theta. So what will be cos cube theta? Cos 3 theta plus 3 cos theta by 4. And that's what we are going to substitute here for sine cube t and cos cube t. So you get 3 sine t minus sine 3t by 4 minus cos 3t plus 3 cos t by 4. Now Laplace transform of t raised to n ft is minus 1 raised to n nth derivative with respect to s of Laplace transform of s. So LTFT will be minus d ds of Laplace transform of s, because we have TFT here. So this now Laplace transform of sine cube t minus cos cube t becomes 1 by 4. This becomes 3 by s squared plus 1 minus 3 by s squared plus 9, because Laplace transform of sine at is a by s squared plus a squared. Laplace transform of cos at is s by s squared plus a squared. So for cos 3t you get, again take out the minus 1 by 4, s by s squared plus 9 plus 3s by s squared plus 1 for cos t. So Laplace transform of TFT will be minus d ds of this. So that will be, now you have to take the derivative. Here we can use the chain rule, so it is, you can take out minus 1 by 4. You get minus 3 by s squared plus 1 the whole squared into derivative of s squared plus 1, that is 2s. This becomes minus minus plus, because derivative of 1 by x is minus 1 by x squared. So plus 3 by s squared plus 9 the whole squared into 2s. Now here we are going to be using quotient rule. The minus and minus will give you plus here, opening the bracket, and here applying quotient rule you get s squared plus 9 the whole squared. S squared plus 9, derivative of s is 1, minus s into derivative of s squared plus 9, which is 2s. Do the same thing here. So s squared plus 1 the whole squared, denominator squared. We have a 3 outside, 3 into s squared plus 1, derivative of s is 1, minus s into 2s. So simplifying all this, you get it as finally 3s by 2, 1 by s squared plus 1 the whole squared. minus 1 by s squared plus 9 the whole squared. I've taken out the 3s. And here you get 1 by 4, simplifying you get 9 minus s squared by s squared plus 9 the whole squared, plus 3 into, this will give you 1 minus s squared plus 1 minus 2s squared, into by s squared plus 1 the whole squared. So basically we have worked out 4 problems finding the Laplace transforms, and it relies heavily on the earlier lessons. I have explained it and given the references of the formulas. So please write along with me and practice. Thank you.